Hello students, welcome back. Let us continue with sample paper 1, section D. We are going to take a look at question number 24. So, if two equal chords of a circle intersect within the circle, then prove that the line joining the point of intersection to the center makes equal angles with the chord. So, how do we do this? First, obviously, we do not understand anything by just reading it. We are going to first draw the circle and the required construction. So let's say I have my circle here, and what does it say? Two equal chords of a circle intersect within the circle. So let's draw two intersecting chords that look equal to each other. So I have two chords, I'll call them AB and CD, or let's say CD, and these both are equal to each other. That means this chord is equal to this chord. Now we need to prove that the line joining the point of intersection to the center. So if this is the center of your circle, then the line joining the point of intersection, so this will be the line out here. Let me call it E. I need to prove that it makes equal angles with the chord. That means I need to prove that angle AE, if this is the center O, angle AEO is equal to angle CEO. So how do I prove this? Now these two chords are equal to each other. So in order to prove any two angles congruent, we can take into account triangles, right? So how do I form a triangle such that through corresponding pair of congruent triangles I can prove these angles congruent? Obviously first we need a triangle. Let's see if I take triangles like this. What will I get? Suppose if let me just take a yellow chalk. Let's say if I join these two, what will I get? I will get these two sides and these two sides equal to each other. So what will we get? Only two sides that are equal to each other. But we need at least one angle or one side to prove that the two triangles are congruent to each other, right? See, because this is the radius out here, right? And this is the radius. So these two sides are equal to each other. Again, this is the common side. But do we have that AE is equal to CE? No, we do not have that. We have that CD is equal to AB. So there's a difference. So we cannot prove the two triangles congruent by SSS test of congruence. Neither do we have any angle. See, this angle we can't really say that it's equal. By what will we say that it's equal? This angle we need to prove that this angle is equal to this angle. So again we cannot take these two sides here. So this construction won't really help. How about drawing perpendiculars like this? So I draw a perpendicular AM to AD and OM perpendicular to OD and ON perpendicular to CD. What do we get? Since O is drawn from the center of the circle perpendicular to the chord, N becomes the midpoint of this chord. And since OM is drawn perpendicular to this chord from the center of the circle, M becomes the midpoint of this chord. So what do we get? That these two are the midpoints, and we see midpoints from the equal chords to the center of the circle, they are equidistant from the center. So what do we get? That OM is equal to ON. So now if you see these tiny little triangles out here, that is OME and ONE, what do you get? You get right angle triangles with hypotenuse as common. You have a right angle and you have one side equal to each other, just because we proved that they are equidistant from equal chords from the center of the circle. So what do we get? We get that the two triangles are congruent to each other by the right angle hypotenuse side test of congruence. So once you prove that the two triangles are congruent to each other, you can obviously prove that MEO is equal to NEO. Why? Through corresponding pair of congruent triangles. But M lies on the line segment AD and N lies on the line segment CD, AB and CD. Therefore, what do you get? Angle AEO is equal to angle CEO. Hence proved. So let's go ahead and write the solution. So given, what I will do is, I have in a circle with center O, chord AB is equal to chord CD, and these chords intersect at point E inside the circle. Correct? What is the next point? That O is joined to E. What do I need to prove? I need to prove that angle AEO is equal to angle CEO. So I'll say proof, starting with my construction. I will say draw OM perpendicular to AB and ON perpendicular to CD. Since OM is perpendicular to AB, what do I get? M is the midpoint of AB, and since ON is perpendicular to CD, I get N is the midpoint of CD. And for both of these, what can you write? Perpendiculars drawn from center of circle to a chord bisect the chord. So now these two are the midpoints of chords AB and CD. Therefore, what do you get? That they are equidistant from the chords. So chords that are equal to each other are equidistant from the center of the circle. So I will say therefore OM is equal to ON, and my reason will be equal chords or chords of equal length are equidistant from the center. This is one of the proofs that we have seen in the chapter itself. So this is point number 1. So now I am going to take into consideration these two small triangles. So what are my triangles? Triangle OME and triangle ONE. So I'll say in right angled triangles, triangle OME and triangle ONE. So when I say right angled triangles, it is both of the triangles are right angle, OME and ONE, because here we have perpendiculars. Okay, I have OM is equal to ON. I'll say from 1. Angle OME is equal to angle ONE, which is equal to 90 degrees. This is through construction. And you have hypotenuse OE is equal to hypotenuse OE. Correct? Therefore, triangle OME is congruent to triangle ONE by RHS test or right angle hypotenuse test of congruence. Therefore, I have angle OEM is congruent to angle OEN by corresponding pair of congruent triangles or CPCT. Let me mark this as 2, or rather just CPCT. But which two triangles we need to prove, which two angles we need to prove equal? AEO and CEO. So instead of OEM, I can take OEA, right? So therefore, angle OEM and instead of M I'm going to take A is congruent to angle OEC. Why? Because these are the angles that we need to prove congruent, right? AEO, so AEO and CEO, so CEO backwards that way. So what is my reason going to be? I have M line on the line segment AB. So AMB and CND. Correct? So I'm just going to reverse this. Angle AEO is congruent to angle CEO. But we need to prove that they are equal to each other. So instead of congruency, I'm just going to write equal to. So angle AEO is equal to angle CEO. And I will say hence proved. So this was about the proof. Question number 24. It's a very important one and can come for at least 4 to 5 marks. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.